Hi everyone. In this video, we'll be talking about the equal shares model for introducing fractions as the process of division. So there's two categories of division word problems, and the equal sharing model uses the sharing type of division. Your book also calls this partitive division. And in a sharing division word problem, the dividend is divided into a specified number of groups determined by the divisor, and the quotient represents the number in each group. For example, if you had a class of 20 children that you wanted to divide into 4 teams and you wanted to figure out how many children are on each team, you could figure this out by forming your 4 teams. And you could say, okay, this child's going to go on this team, this child's going to go on this team, this child will go on this one, and this one will go here. So we have one child on each team. Then we can put a second child in each team and a third child and a fourth child on each team. And I think I might have actually miscounted because you should end up with 5 children on each team because 20 divided by 4 equals 5. And so this is an example of sharing division. In a measurement division word problem, the dividend is divided into groups of a specific size, and the quotient represents the number of groups. For example, if you had a class of 20 children and you divided them into teams of 4 people each, this measurement division would tell you how many teams there are. So if I split these 20 children up into teams of 4, I would get 5 teams altogether. And both of these division problems are solved by doing 20 divided by 4, but the meaning of the division is different. In sharing division, 20 divided by 4 means that you're taking 20 children and splitting them up into 4 groups. With measurement division, you have 20 children and you're dividing them up into groups of 4. And that means that the quotient or the answer to the division also represents something different. In sharing division, the quotient represents how many children are on each team, versus in measurement division, it's how many teams you have. So our textbook suggests that the best way to introduce fractions to students is with the equal sharing model because of the rich mathematical thinking that can develop through using this model. So the basic idea is that you introduce a word problem that does not involve any fractions, but requires fractions to be able to solve it. So as an example, let's say Maggie has 8 slices of pumpkin bread and she wants to share them equally between herself and 2 other friends. And we want to know how much pumpkin bread each person gets. So I want you to imagine that you're a student who has not learned about fractions yet, and I want you to think about how would you solve this problem. So pause this video, draw some pictures, and determine how you would describe your answer if you were a child who didn't know how to write fractions yet. Okay, so now that you have your example of how you would describe your answer if you didn't know about fractions, let's talk about some common ways that your students may respond to a question like this. So when you introduce a problem like this to your students, different students will have different approaches to the problem. And by facilitating a conversation about their different strategies, you can help all of your students understand fractions on a deeper level. So, in our reading for this week, we explore a variety of student responses to equal sharing problems like this. And in this video, I'm going to summarize the categories that these student strategies usually fall into. So, the first category is non anticipatory coordination. So, students who use these strategies don't anticipate the problems that come up when you're dividing 8 pieces of pumpkin bread among 3 people. They just start dividing and then deal with the issues as they go. So a student may give 1 piece of bread to each person, like this, and then they may give another piece of bread to each person, and then they'll puzzle over how to divide the remaining 2 pieces. And they may make an error, like giving 1 person a whole and then giving the other 2 people a half of this last piece. And when students make an error like this, you can deepen their mathematical thinking by asking a question like, well, is it sharing fairly if 1 person gets a whole, but these 2 people only get halves? Another mistake that they may make is to split both pieces into halves and give each person one of the halves. And in a case like this, you may ask, well, did you give away all of the pumpkin bread? And this will help them realize that they made the mistake because this last half was not given to anyone. Other students may solve the issue of dividing the remaining two pieces correctly. So they might give each person a half, just like this one that I've drawn here. And then they might take this last half and split it up into three equal pieces and give each person one of those pieces. And they'll say that each person will get two wholes, one half, and one third of a half. And this is a correct answer because if you do 8 divided by 3, this does equal 2 plus 1 half plus 1/6, which is a third of a half. Other students may take the last two pieces of bread and they might split each of them into three equal pieces and give each person one piece like this. And students who do it this way will say that each person gets two wholes and two thirds, which is also correct because if you do 8 divided by 3, this does equal 2 and 2/3. So, the distinguishing factor that makes a strategy fit in the category of non anticipatory coordination is that the students don't anticipate the issue of having a remainder when they divide the whole numbers. And so they'll resolve the remainder after they've divided up the whole numbers. The next type of strategy you may see students use is the one at a time additive coordination strategy. So, students who use this strategy will split up each piece of bread equally between the three people. So, they might say, well, this piece of bread can get split up into three equal pieces, and each person will get one third. Then, this piece of bread can get split up into three equal pieces, and each person will get another third. And then this piece of bread can get split up into three pieces. This one will get split up into three pieces, and so on and so forth. And they'll figure out the answer to 8 divided by 3 as being one third plus one third plus one third plus one third 8 times. Because each piece of bread is split up into thirds and each person gets one. And so ultimately, they'll say that 8 divided by 3 equals 8 thirds, which is correct. And this is called additive coordination because they're thinking about it as the fraction from each piece of bread being added all together to give you the total amount of bread that each person gets. A similar type of strategy is the groups of items additive coordination approach. So, students who use this strategy will divide up the slices of bread in groups. So, they'll know that they can give 2 slices of bread to each person because 2 times 3 is 6. But they won't be able to give everyone 3 slices of bread because 3 times 3 is 9 and they only have 8 slices of bread. So, by this reasoning, they're anticipating the fact that they will have a remainder, and then they split up the remainder by groups. So, they kind of start off and they say, okay, well, I can give 2 slices of bread to each person, and then I'll have 2 pieces of bread left over. And so they might say, okay, well, I'm going to split these pieces of bread into halves and give each person a half. And then they'll split the next or the and then they'll split the last half of bread into three equal pieces and give each person a third of that last half. And so they'll get the answer that 8 divided by 3 equals 2 plus 1 half plus a sixth. But they'll probably describe the sixth as being a third of a half. But they'll probably describe 1/6 as being a third of a half. And this strategy is similar to one of the strategies I mentioned on the non anticipatory slide. The key difference here is that these students anticipate the remainder by predicting that each person will get 2 whole pieces of bread, but not 3 because 3 times 3 is 9. While the other student on the non anticipatory slide just dealt with the remainder after they divided up the pieces of bread one by one and they realized that there was a remainder. Another student strategy that's rather rare but displays a deep conceptual understanding of fractions is multiplicative coordination. So, in this strategy, students will say that one slice of bread divided between 3 people is one third. And then, since there are 8 slices of bread, each person will get 8 thirds. So, this is kind of similar to the one at a time additive coordination, but the difference is that with additive coordination, The student will cut up each piece of bread and find the answer of 8 thirds by doing 1 third plus 1 third plus 1 third 8 times. While a student that uses multiplicative coordination realizes that each person will get 1 third from each of the 8 slices. So they're thinking about it as 1 third times 8 equals 8 thirds rather than doing 1 third plus 1 third plus 1 third 8 times. And this is why we call it multiplicative coordination. The last category of student strategies is also pretty rare, and it tends to show up when the divisor is easily halved. So I'm going to adjust this word problem slightly, and instead of sharing 8 slices of bread with 3 people, I'm going to share 9 slices of bread with 4 people. So a student who uses ratio reasoning will split the people into equal groups and then split the bread into equal groups to coordinate. So they may split the people into groups of 2, and then the bread will be split into 2 groups of 4.5. And then they'll split each of these groups into 2 more groups to show that each person gets 2.25 of a slice of bread. So they might say, okay, well, if I split the people on the left into 2 groups, I have 1 person in each group. And if I split the bread into 2 groups, I'll have enough to give each person 2 slices of bread because that's splitting that part in half. And then I also have to split this half slice of bread into halves. And so that shows that each person gets 2 wholes and 1/4. And then they'll do something similar on the right-hand side where they split these 2 people into 2 equal groups, split the bread into 2 equal groups, where each person gets 2 wholes and 1/4. And so that's the idea of how ratio reasoning works. So remember, these 5 categories are not rigid, and some student strategies may include reasoning from 2 or more categories. Each student's reasoning will be different, and the important thing is to listen to their reasoning and use their way of thinking to ask good questions and facilitate meaningful mathematical discussions. So you're likely not going to sort your student strategies into these formal categories while you're teaching, because you'll have a lot of other things on your mind while you're juggling classroom management and the flow of the discussion and all of the other things that go through the mind of a teacher. But the reason why these categories are helpful is because if you take the time now to study the variety of typical student responses and understand the subtle nuances and differences between the students' thinking, you'll be better equipped to understand your students' reasoning when you're deciphering their drawings and their clumsily worded explanations when you're on the spot teaching in your classroom. So I hope this video was helpful, and I hope you have a great day. If you have any questions, let me know.